the whole number.
What about the number inside the absolute value? So if I say the absolute value of 4, you tell me what? Do you know where Helen does? If I say the absolute value of 4, you say what? 4. If I say the absolute value of -4, you say?
-4.
4. Because what does absolute value do?
Opposite. It changes it.
It makes everything positive. So absolute value has this weird characteristic that we normally don't see. So what we're talking about today is not actually a linear function. Okay, it's a function, it's just not linear. So you're gonna notice that the graphs today look very different than the graphs we have seen before. Now, we also have learned how to graph in a way that isn't attached to linear functions. Okay, and we learned that last trimester. How are we graphing last trimester? So like if I said, class, graph y equals 2x minus 3, and it was last trimester and you didn't know m and b, what would you do?
-3 and 2.
We would make a table and we would plug in some values, right? So let's say this time around that we're gonna do that same idea, except now you don't need to write this down. But now we're gonna graph the absolute value of x. So I'm gonna pick some very specific numbers here, which don't really fit our linear values, but.
Why isn't 0, 1, -1?
Because I need to pick some more specific values to get a bigger picture here, okay? So I'm just picking some random ones in here. So what is the absolute value of -2?
2.
What is the absolute value of -1?
1.
What is the absolute value of 0?
-1.
What? No, what's the absolute value?
1.
Right, because it's always positive, so our absolute value of 1 is 1, and then 2. So if I go to plot these ordered pairs, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, what shape do we get? A V. Parabolas are those U shapes that are for quadratics. This is not a quadratic because it doesn't have an exponent of 2. So absolute values make this V. So everything we're looking at today, right, is no longer just this line that goes all the way across it, but this V, because what's going to happen is at some point those negative values become positive, and so our line sort of gets bent in half. Okay, so absolute value equations still have a general format. Okay, this one says y equals a times the absolute value of x minus h plus k. Now, when we are talking about formulas, we said if something has a subtraction sign, what did we say that would do to it?
It would become a negative.
What do you mean it would become a negative?
Oh.
What becomes a negative?
The number 8.
Right? A positive would become a negative. So a negative would become a positive. So we could also read this as the opposite. Right? So that's going to be important here in a minute. Okay. A tells us the slope, and I'm putting this in quotes because it's not actually a slope, but it's as close to slope as you guys can relate. Okay, it tells us the slope of the line. However, our line, right, is getting bent sort of in half. It's getting bent up. So we're going to have to consider that slope as a positive,
And a negative.
and we are also going to have to consider it as a negative. For the exact reason we just said with absolute value, right? The absolute value of 4 is 4. The absolute value of -4 is 4. So both negatives and positives get that exact same property, so we have to consider both of them. H and K are used to give us the starting point of the graph. Okay, so the other thing that we are going to be able to find is an ordered pair. So if we can find something that's similar to slope, and we can find a point, this is going to be similar to graphing in point-slope form. But just like we said, we're going to have to use the opposite sign of H. I don't have a solution for you. It is confusing. The best thing I can tell you is just to know that that negative in the formula says to take the opposite sign. Don't have a whole lot of a better answer for you, but point slope form, we take the opposite sign of both the x and y value. Here we only take the opposite of the h. And this one stays the same. Absolute value graphs, just like we said, make a V-shaped graph. So if we're good with point slope form, these really aren't that different. We just need to make sure we're getting the right other half of it every time. Dragging my eyes bonker. I'm sorry, guys. Hopefully we'll get it fixed later today. It'll be good to go tomorrow. Oh, was the cable plug in somewhere there? No. Y equals 2 times the absolute value of x minus 3 plus 1. So just like in point slope form, there are two things we are going to find here. We're going to find a point, and we're going to find a, which is as close to the slope as we can get. Okay, so if we look at this, what value does a equal in this one?
3.
A is in front of the absolute value, right? Our formula was y equals a, so a is going to be 2. Okay, and then what is our starting point going to be? Okay, so here's our first one. We're making it positive because we are taking the opposite sign. So it looks negative, so we're going to write it as a positive. Positive 1. And then very similar to point slope form, which one do we think we're going to graph or plot first?
3 over 1.
3, not 3 over 1, but 3 comma 1, right? We're going to plot the ordered pair. 3, comma 1. Okay, then we are going to think about a as the slope, but we need to think about it as both a positive option and a negative option, which means we are going to think about this as 2 over 1, but we are also going to think about this as 2 over negative 1. The key here is that the denominator is where we are giving it both signs. Okay, so we need a positive denominator and a negative denominator. Do not change the top value. It is the denominator. Okay, so we're going to go up 2 over 1. So up 2 over 1, 2 over 1, right? I can do as many of those as I want. But I'm not going to make a big long line that goes across my graph.
No, you want to make
Okay,
Like a V.
instead I need a V. So instead I need this other side to come from this negative. So now from this same starting point of 3 comma 1, I'm now going to go up 2,
and then
left
right,
1. Okay, so these are two sort of rays, is the technical geometric term. Right from here I'm going up and out, and it continues. And then same thing here.
So I have a question for the next graph then.
So hang on, let's get any questions on this graph?
No.
You see where that came from? Okay, so let's look at this graph over here on the right. And we're going to find those key pieces first. So what does A equal on this one?
-3.
-3.
Okay, so it does equal -3 instead of.
Yeah, because we don't flip the sign of A.
Okay, that's
We only flip the sign of the number that's paired with X on this one.
okay.
Okay, so then we need to find our ordered pair that we're going to start with. So what's going to be our starting point?
2 thirds. 2. Oh.
-2.
+3.
negative 3.
Dang it.
Okay, so we're going to plot the point. Negative 2, negative 3. Right? I changed the sign of my H. I did not change the sign of my K. Okay, now I need to consider my slope, right? This angle of these sides as a positive and as a negative. So I need to consider it as negative 3 over 1 and negative 3 over negative 1, right? Is the denominator that I'm giving that positive and negative to. I am not changing the sign of the numerator.
What?
You put down.
Yes, Leah?
Will it always be negative 1 under it?
Well, if it's a fraction to start with, it's just changing the sign of the denominator. We'll look at some of those here in a little bit. So from here, I'm going to go down 3, right 1. Down 3, right 1. And what am I going to do on my other one?
Go the other way.
Down 3, left 1. Okay, so one of my students said, so basically I just want to do the same thing on each side, but once go to the right and once go to the left. Yes. If you prefer to think about that way rather than positive and negative, yes, that's what you're doing. Okay, because absolute value graphs have something called a line of symmetry, which means the right-hand side mimics the left-hand side. So whatever we do to the right, we're doing the exact same thing to the left, just moving the opposite direction.
So are they always going to be up like a V, or can they be upside down?
It can open up or it can open down, but it cannot open sideways. If you get a V that's sideways, then you're no longer in a function, and then we got a problem.
Okay.
Okay? Yes, Gary.
For like the points, why would 2 be negative 2?
Why would 2 be negative 2?
Like inside the
Okay, so are you concerned with this negative 3 being positive 3?
no,
Why not?
because it's positive.
Okay, so it's the opposite, and it's the same reason over here. This has nothing to do with the absolute value bars. It has to do with the fact that the formula that we had up here says minus h. And minus is the same thing as a negative, which is the same thing as the opposite of. Okay, so we're taking the opposite of h. Nothing to do with the absolute value bars and it always being positive. Those are two separate things. So here's what I want you to do. I want everyone to